Hello students, welcome to classroom. Today we will be learning about balancing again. In the previous video we have learned how to balance chemical equation. Today we will be learning about a special type of balancing of chemical equation whereby we have to convert the word equation into skeletal equation. Then after converting into skeletal equation, we will balance them again. So it's a two-way process. So let's learn that together. I'll be doing the questions from your textbook. So if you have your textbook, I will recommend you to open the textbook. We will be doing from the exercise questions. So I have your textbook here with me. So page 15, question number 5. Translate the following statements into chemical equations and then balance them. So we will be doing these questions one by one. So let us start. So we'll be doing question number 5. Okay. So the question reads, question number 5A. Hydrogen gas combines. Hydrogen gas combines with nitrogen to form ammonia. With nitrogen to form ammonia. So this is the first question. So how to solve this such type of question? See, students, this type of questions they ask in exam and it's not very difficult. So this is how word equations are written. Okay, this is a statement, this is a reaction given in sentence form, and then we have to convert this into skeletal equation. So in order to convert this into skeletal equation, we need to use the standard symbols. Okay, that's what I have been telling you in the previous class. So let's convert this into skeletal equation. So the first thing is to identify the keywords here. Okay, the keywords here are hydrogen, okay, nitrogen, and ammonia. So if you are familiar with word problems or in mathematics, it will be very easy for you. So let us start. So hydrogen. So hydrogen, okay, is an element. So hydrogen is written as H2. Okay, remember that hydrogen is written as H2. Okay. Then hydrogen gas combines will become plus, all right, with nitrogen. So it combines with nitrogen, so again N2. Okay, to form means arrow. Ammonia is NH3. all right, so hydrogen gas combines with nitrogen to form ammonia. Now this is the skeletal equation of the above reaction. Now we have to balance this. Okay, we have to balance it. So let's balance this. So you know how we have to do balancing. So once again, let us remember the steps. Okay, the steps to balancing. Okay, steps. So the steps of balancing, the first one is, what is the first one? To identify the elements. Identify the elements. So identify the elements. So the element here is hydrogen. We always start from this side. So it's hydrogen. The next element is nitrogen. So the same elements will be found here in the product side. So it's hydrogen and nitrogen. All right. Now what we do is the second step. We are done with the first step. The second step is count the number of atoms. So count the number of atoms. Okay, we will first start from the reactant side. So how many atoms of hydrogen do you see? Do you see this number? Yes, 2. So 2 hydrogen atoms are here. Do you see this number? Yes. So there are 2 nitrogen atoms. Sorry. Now we go to the product side and count. How many hydrogens do you see? So do you see this 3? Okay, this 3 is below hydrogen. Okay, so this position I have already told you. This position is also known as the subscript. Okay, so this 3 belongs to hydrogen. Remember, this 3 does not belong to nitrogen. Okay, This 3 belongs to hydrogen, so you will write here 3. So 3 atoms of hydrogen. Then how many atoms of nitrogen? Do you see any number below nitrogen? Do you see any number below nitrogen? So we have this position here below nitrogen, but do you see any number here? Do you see any number here? No, it's not. You do not see any number here. If we do not see any number here, means it is 1. 1 is always there. So the number of hydrogen atoms is 1. Okay. Now, the third step is to balance. Now let's balance it. Okay, if it needs balancing, we'll balance it. Some chemical equations, they are already balanced. So let's have a look whether this equation is balancing or not. So I see 2 hydrogen on the reactant side. There is 3 hydrogen on the product side. Are they balanced? No. So this is not balanced. So we have to balance this. 2 nitrogen in the reactant side, 1 nitrogen in the product side. Are they balanced? Again, no. Not balanced. So they need to be balanced. Okay. So whom should I balance first? Well, 2 plus 3, the sum is less. 3 plus 2, the sum is 5. Okay, more sum, less sum. I will start with the less sum. Okay, so 2 plus 1 is 3. So let's start with nitrogen. So 2 nitrogen here, 1 nitrogen here. So we will be balancing here. Okay, so with what number? Okay, remember here, we will be multiplying with the number. Okay, we will be multiplying with the number. So with what number should I multiply this 1 so that I get 2? So the answer is 2, isn't it? You multiply this with 2. So if you multiply this with 2, this becomes 2 nitrogen. Nah? 2 into 1 gives you what? 2 nitrogen, isn't it? 2 nitrogen. Yes or no? 2 nitrogen. So you will multiply this nitrogen, which means this nitrogen, okay? So with 2. So you have put here 2. Alright. So by putting 2 here, the number of nitrogen becomes 2 nitrogen, okay? 2n, 2n, okay? 2n. So 2 nitrogen here now, okay? 2 nitrogen here. So nitrogen is balanced, okay? But this nitrogen, these 2 also belongs to hydrogen. Yes or no? These 2 also belongs to hydrogen. So this is 2 3s are 6. So the number of hydrogen has now shot up to 6. Okay, has shot up to 6. So we have 6 hydrogen here. How many hydrogens are here? 2. Okay, how many hydrogens are here? 2. So now this side is already more, this side is less. So we have to add a number here. Okay, so you know what we do. We will multiply with the number, isn't it? We multiply with the number. So what number do I write here so that the number becomes 6? The answer is 3. You have to multiply with 3. So you have to multiply with 3. So you have to put here 3. Okay, so 3 2s are 6. So now the number has become 3 2s are 6. So this side also has become 6 hydrogen. Okay, 6 hydrogen. So same 6 hydrogen, 6 hydrogen, 2 nitrogen, 2 nitrogen. So this is balance. So the balanced chemical equation is 3. We were to write 3 here. We don't need to write any number here. And this number 2. Alright. I hope it is clear. Now we go to the next question, question number B. Okay. Question number, what is question number B? Question number B. Hydrogen sulfide gas. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. To give water and sulfur dioxide. Alright, so let us convert this word equation into skeletal equation now. So, well, alright, hydrogen sulfide. Now see, the question reads, hydrogen sulfide gas burns in air to give water and sulfur dioxide. So, hydrogen sulfide, see, hydrogen sulfide, you have to read them together. Okay, hydrogen sulfide is a compound. Now, the formula of hydrogen sulfide is H2S, H2S. Now, there will be a question in your mind. how will we know? Okay, how will we know that the formula of hydrogen sulfide is H2S? Okay, now there is a way to find this. Okay, there's a way to find the formulas of compounds which we have already learned in class 9. Okay, you have already learned in class 9, chapter 2 or chapter 3. There's a chapter in class 9 in science where you are taught how to construct the formula of molecules and compounds. Okay, so let's do this. Okay, no need to worry, I'll teach you again. So hydrogen sulfide. So hydrogen sulfide, how do we get the formula of hydrogen sulfide? See here. So in the rough you can write like this. So in the rough you can write, let's make a rough here. Okay, so write hydrogen sulfide, hydrogen. Okay, sulfide means sulfur. Okay, class, so write sulfur. Now next what you have to do is write the symbol. You have to write the symbol now. So write the symbol of hydrogen, which is capital H. Write the symbol of sulfur, which is capital S. Okay, and below that you will write valency. So what is the valency of hydrogen? The valency of hydrogen is hydrogen having atomic number 1, valency is 1. Okay, sulfur has valency 2. Okay, sulfur has valency 2. Okay, I'll explain to you later what is valency also, but for now you can just remember that sulfur is not stable. Sulfur has atomic number 16. Sulfur is atomic number 16. So the arrangement of atoms for sulfur will be, the arrangement of electrons for sulfur will be 2, 8, 6, is it not? 16, 8 plus 2, 10, 10 plus 6, 16. So this last shell has 6 electrons. Okay, has 6 electrons, and 6 is not the stable number. The stable numbers are 2, 8, okay, 18, likewise. So 6 not being a stable number, sulfur will want to be stable, so he will aim for, sulfur will aim for 8. But the only way, okay, that this 6 can become 8 is by receiving 2 electrons. So if he receives 2 electrons, he can become stable. So this is the reason why the valency of sulfur is taken as 2, because sulfur needs to receive 2 electrons to become stable. Okay, some elements they receive, some elements they don't have. Okay, so we will discuss more on this, but for now, okay, assuming that you know the valency, so you just have to write the valency here. Okay, so after that what you do is you do cross multiplication. You do cross multiplication and then you get the formula. You get the formula. The formula is, we'll always start from the left hand side first. It will be H2S. Okay, so that's how you write the formula of H2S. So hydrogen sulfide formula is H2S. Gas burns in air. So burns in air means plus air. Air means oxygen. Okay, class. So oxygen. Okay, oxygen, O2. Okay, air means oxygen. Let's keep some space here. Then to give, so arrow. Okay, to give water. Okay, water, we all know the formula of water. What is the formula of water? H2O, isn't it? So H2O, N means plus sulfur dioxide. Okay, carbon dioxide formula is CO2, sulfur dioxide formula is SO2. So SO2. Okay, now we have to balance it. So let's balance it. So the first thing that you have to do is identify the elements. Identify the elements here. So hydrogen, then sulfur, then oxygen. The same elements will be found in the product also. So H, S, O. Okay, we are done with the first step. Now we go to the second step. Count the number of atoms. So count the number of atoms. How many atoms of hydrogen here? Do you see these 2? Yes, so there are 2 atoms of hydrogen here. How many sulfur atoms are here? I do not see any number, that means 1. By default it is 1. How many oxygen atoms do you see? 2. So right here 2. Okay, count here for hydrogen. How many hydrogen atoms do we see? 2. So right here 2. How many sulfur atoms do we see here? I see only 1. These 2 belongs to oxygen, so there's only 1 here. So 1. Okay, and then how many oxygen do we see? How many oxygen are we seeing? We see 2 here. Okay, and then nothing means 1. So 1. 2 plus 1 giving us 3. Are you following? Is it all right? Okay, so now which is balanced and which is imbalanced? So we see that hydrogen is balanced, okay, sulfur is also balanced, whereas oxygen is not balanced. Okay, so let's try to balance oxygen. Okay, so we have 2 oxygen atoms here and 3 oxygen atoms here. This side is more. Okay, this side is more, so this has got more oxygen atoms, this has got less, so we should add, okay, we should add some atoms here. So we will be adding a number here. Okay, we'll try to make them same, but there is a catch here. Okay, there's a catch here. See, there are 3 oxygen atoms here, there are only 2 here. Now oxygen is only found here. Okay, you do not find oxygen here in this compound, whereas here you find oxygen in both the compounds. Water also has oxygen, sulfur dioxide also has oxygen. Okay, so these are a little bit of a challenge, but don't worry. Okay, with practice you will be able to overcome this. So all you need is practice. Okay, so now 2 here, 3 here. Okay, so here what I have to do is, well, 2 cannot be made into 3 and 3 cannot be made into 2. Okay, 2 and 3, okay, they cannot. Okay, 2 cannot be made into 3. Okay, because usually we multiply with the number, is not. So if I multiply with 1 here, then it becomes 2 only. So multiplying with 1, we get the same value. If we multiply with 2, this will become 4. If we multiply with 3, this will become 6. Okay, likewise. Then so if I multiply with 2, it becomes 4. Okay, if I multiply with 2, it becomes 4, but this is 3 again, so they're not same. Okay, so usually in this case what we do is we go for common numbers. So usually in this case we go for common numbers, so I should be going for 6. So 2 3s are 6 and 3 2s are 6, like that. Okay, that will be the case, okay, usually. But here there's a catch. The catch is I see that oxygen is present in both of these. Okay, so that causes a problem. So what I do is that I cannot go for this technique, so I'll just go for a simple technique, and which is, if I observe carefully here, okay, by putting 2 here, okay, by putting 2 here, the number of oxygen can be changed to 4. Yes or no? So this can be changed to 4. So we have 2 oxygen here, and now these 2 will also belong to oxygen here. So 2 oxygen here plus 2 oxygen here, together the number of oxygen shoots to 4. Yes or no? Okay, now here we were having only 2, isn't it, earlier? Now here, though, there's only 1 oxygen here, oxygen is found only here, so it's easy. Okay, I can write a number here. So 2 oxygen here, 4 oxygen here, I have to make it 4, so just put 2 here. By putting 2 here, this becomes 4, so 2 2s are 4 oxygen. All right, now oxygen is balanced. Okay, sulfur is already balanced, hydrogen is also balanced, so this is the answer. Okay, for question number B, this is the balanced chemical equation. Okay, 2 hydrogen. Now 1 sulfur. Oh wait, oh yes, I think it's correct only. Oh wait, no, hydrogen also is there now. Now that's why we have to be careful. Okay, now this 2 is used by oxygen, but this 2 will also be used by hydrogen, isn't it? Yes, so now the number of hydrogen will change. So 2 2s are 4, so the number of hydrogen has increased to 4. Now we have only 2 hydrogen here. Okay, so this side is more, so we have to add number here. So what should I put here so that the number becomes 4? It's 2 again. So by putting 2 here, 2 2s are 4, so this becomes now 4 hydrogen. Okay, hydrogen has been balanced, but remember that this 2 also belongs to sulfur. Okay, so now this number shoots to, it becomes 2 sulfur we have, whereas here we have only 1 sulfur. So now we have to balance here. So the sulfur has become unbalanced. 2 sulfur here, 1 sulfur here. What should I do? Put 2 here. By putting 2 here, the number of sulfur has changed to 2. But wait, these two belongs to sulfur also, these 2 belongs to oxygen also. So again, the number of oxygen will change. So this becomes 4 oxygen plus 2 oxygen. So 2 2s are 4 oxygen plus 2 oxygen, 4 plus 2, 6. So the number has changed from 4 to 6. Okay, so now this side has become less again. So we have to increase the number of oxygen here. So there is 4, no problem. So to make it 6, I have to multiply with 3. So 3 2s are 6. So if I multiply with 3 here, the number becomes 6. Okay, so now you check, everything is balanced. 4 hydrogen balance. 4 hydrogen I see here, 4 hydrogen I see here, correct? 2 sulfur I see here, 2 sulfur I see there. 6 oxygen I see here, 2 from here, 4 from there. 4 plus 2, 6 oxygen. And this is how the equation gets balanced. Yes or no? All right. Next, let us write the next one. Let me erase this. I hope you are following. Okay, so you will follow. These are not very difficult. Let me just erase the entire thing. Okay, let us remove this also, because later on we will have to write again. Oh, sorry. So now A is done, B is done. Now C, question number C. So let me have a look at the question number C. So barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate barium sulfate. So this is the question. Now together let's convert this into a skeletal equation. So now barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. So this is a lengthy question. Okay, no need to get scared, it's easy. So these are important words here. Barium chloride. Okay, barium chloride. Now barium chloride is a compound. Okay, and I do not know the formula of barium chloride. Okay, I don't know the formula of this compound, so I have to derive the formula of barium chloride. So we will have to do what we have been doing earlier. So write barium chloride here, barium chloride. Now barium chloride, so the symbol of, you have to write the symbol here. Okay, symbol of barium is Ba, isn't it? And chloride is chlorine. Okay, so it's Cl. Okay, next you have to write the valency. So what is the valency of barium chloride? Valency of barium chloride. So barium valency. What is the valency of barium? Barium has valency 2. Okay, valency 2, and chloride has valency 1. Okay, so now you will do cross multiplication and then you will get your formula. The formula is BaCl2. So the formula is BaCl2. So barium chloride is BaCl2. Are you following? Okay, BaCl2. Next, barium chloride reacts with, so plus aluminum sulfate. We have to derive the formula for aluminum sulfate also. So Aluminium, aluminum sulfate. So what do you have to do? Write the symbol first. Symbol, aluminum symbol is Al. Sulfate is, okay, sulfate, okay, is a polyatomic ion. So here you will have to refer to class 9 textbook again. So there is a table, okay, which if it's possible, I'll share very soon. So sulfate, okay, sulfate is a polyatomic ion, so you will have to study this. Okay, so you will not be writing sulfur here. Okay, if you write sulfur here, that is wrong. Sulfate is SO4, SO4. Okay, so SO4. Okay, so you have to know that sulfate formula, you have to know that. Okay, then the valency of aluminum, okay, and the valency of sulfate you have to know. So valency of aluminum is 3 and valency of sulfate is 2. Okay, so now what you will do, this is the valency. Now we wrote the valency. Okay, now you do cross multiplication. So the formula becomes, so the formula will be Al2SO4 bracket 3. Okay, so the formula is Al2SO4 close the bracket 3. All right. Barium chloride reacts with aluminum sulfate. We have just got the formula of aluminum sulfate to give. So arrow to give means this arrow. Aluminum chloride. Okay, now again we have to derive the formula for aluminum chloride. So aluminum chloride. So let us find the formula for aluminum chloride. Where do I do this? Okay, aluminum chloride. So aluminum chloride. So okay, AluMinium, aluminum chloride. So aluminum chloride. So the symbol of aluminum. Don't forget to write the symbol of aluminum. Symbol of aluminum is Al. Okay, and chloride will be Cl. Okay, chlorine, Cl. Okay, then you need to write the valency. So what is the valency of aluminum and chlorine? So aluminum has valency 3, chlorine has valency 1. So valency of 3, chlorine is valency 1. So cross multiplication and you get the formula. The formula is AlCl3. Okay, AlCl3. So the formula is AlCl3. Okay, so aluminum chloride formula has been derived, and you get what? You get a precipitate of barium sulfate. So now we have to get derive formula of barium sulfate. So barium sulfate formula. Let me derive here. So barium sulfate. Barium sulfate. So barium is Ba. Okay, this is the symbol. Remember this pattern. Okay, symbol, then valency, then formula only. Barium, and sulfate is, we already wrote the formula of sulfate. This is not SO4. So sulfate is SO4. Okay, SO4 valency is 2. Barium valency is how much? How much is it, right? Barium valency is 2, is it not? 2. Okay, now see here. 2 and 2 can cancel. Okay, and you're left with 1. Okay, so cross multiplication now you do. So you will get, this is the valency I wrote. Now time to write the formula. Formula will be Ba into 1 Ba, SO4 into 1 SO4. So plus BaSO4. Alright, so this is the skeletal equation of the above reaction. Now we have to check for balancing. So let's try the balancing together. The first step is to identify the elements. So identify the elements. We always start from this side. Okay, so the elements, we will identify them one by one. The first element is barium. The second is chlorine. Third is aluminum. Fourth is sulfur. Fifth is oxygen. Is it not? Barium, chlorine, aluminum, sulfur, oxygen. These are the elements. Okay, now the same elements will be found here, so you just copy them as it is, because whatever elements we find in the reactant, the same are also found in the product. Alright, now next step, count the number of atoms. Okay, count the number of atoms. So how many barium? 1. Okay, how many chlorine? 2. How many aluminum? 2. How many sulfate? See, both sulfur and oxygen are inside the bracket. Outside the bracket we have 3. This 3 belongs to sulfur. This 3 belongs to oxygen also. So how many sulfur? If 3 belongs to sulfur, then how many sulfur are there? There are 3 sulfur. Okay, so 3 sulfur. And then how many oxygen? Well, 4 belongs to oxygen only, but this 3 also belongs to oxygen, so it will be 4 times 3, or 3 into 4. 3 4s are 12. Okay, next we go here. How many aluminum? 1 aluminum. Okay, how many chlorine? 3 chlorine. How many barium? 1 barium. How many sulfur? 1 sulfur. How many oxygen? 4 oxygen. Yes or no? Okay, now which are balanced and which are not balanced. Okay, so barium looks balanced as of now. Chlorine is not balanced as of now. Aluminium also not balanced, okay, sulfur also not balanced, and oxygen also not balanced. So with whom should I start? Well, I will start with aluminium because the numbers are less, isn't it? 2 plus 1 3, okay, this is 5, 3 plus 2 5, this is 3 plus 1 4, so I'll start with aluminium. So 2 aluminium atoms here, 1 here, so this side is less, so I will deal with this side, okay. So 2 aluminium, so I have to make this 1 into 2. So how do I make this 1 into 2? By multiplying with 2, isn't it? So by multiplying with 2, you will get 2 aluminium. That means I have to write here 2. Whatever number you are multiplying goes here, okay. So you get 2 aluminium now, okay. So 2 aluminium, 2 aluminium, 2 aluminium, aluminium gets balanced. But remember that aluminium is with chlorine, so this 2 also belongs to chlorine. So aluminium has already used this 2 and has made himself to aluminium. This 2 will also be used by chlorine, okay, which will be 3 times 2, so this becomes 6. So 3 times 2 is 6, so the chlorine number has shot to 6. 2 3s are 6, okay. Now which one should I balance? Still I have chlorine to balance and sulfur to balance. So now since the total of sulfur is less, 3 plus 1 is 4 only, I will balance sulfur. 3 atoms of sulfur here, 1 atom of sulfur there. So let's balance sulfur. So I'll be balancing that side. So only 1 sulfur here. So I have to make it 3. So I multiply with 3. Becomes 3 sulfur. Okay. So I put here 3. By putting there 3, the number of sulfur has become 3. But remember, this 3 will also affect barium. So barium number now becomes 3 barium. Then this 3 will also affect oxygen. So this becomes 3 4s are 12. So 12 oxygen. The number of oxygen is short to 12 oxygen. Okay, 12 oxygen. 12 oxygen. So barium, which was earlier balanced, has now become unbalanced. Okay, this happens. Okay, previously balanced numbers, balanced atoms can also become unbalanced. Okay, in the course of balancing chemical equations. Then to whom do I balance now? Well, see, the number of oxygen has automatically balanced, so good. So oxygen is balanced, sulfur is balanced, aluminium is balanced. Now all is left is barium and chlorine. Now to whom will I balance? I'll balance barium first. So I see 3 barium there. Okay, so I have to make 3 barium here, so I put 3 here. By putting 3 here, this becomes 3, so 3 barium. Okay, but this 3 also belongs to chlorine. So chlorine already has 2 atoms, so these 2 will multiply with 3 and give you 6. So the number will change to 3 2s are 6. So you are getting 6 chlorine. Yes or no? So now you check, are they all balanced? 3 barium balance, 6 chlorine atom, 6 chlorine atom balance, 2 aluminium balance, 3 sulfur balance, 12 oxygen balance. Are they balanced? Yes, indeed it is balanced. Okay, so the question number C, the balanced chemical equation looks like this. So we put 3 here, and we had to put 2 here, and we had to put 3 here. All right, now we go to the next question. So once again, okay, give importance to this. Okay, if you know this, I have shown you the formula. If you can do this, then converting mode equation to skeletal equation is a piece of cake for you. All right, now we go to the last question for today's class, which is the fourth question, number D. Like I said, this can serve as a notes for you, so always write this down. Okay, now the fourth question number D. Okay, potassium metal reacts with water to give potassium hydroxide and hydrogen gas So let us do this question together. Now I want you to try. You can try by pausing the video and check later whether you can get the correct answer or not. Now, yes, so let's convert this reaction into skeletal equation. So the keywords here are potassium. Potassium is a metal, so I need to write the symbol of potassium, which is capital K. Reacts with water, so plus water. We know the formula of water, isn't it? So we all know the formula of water is H2O. Okay, to give means this arrow. Potassium hydroxide. Now once again, I need to go back to those formula. So potassium hydroxide. So I have to derive the formula of potassium hydroxide. Okay. So how is the formula? First of all, you write the symbol. Write the symbol. Symbol of potassium is K. Hydroxide. Again, this is a catch. So you have to go back to class 9 science and check out. Okay. There's a table. Okay, very important table of polyatomic ions. You have to know that. Okay, you have to study that. Okay. So refer to that. Hydroxide is OH. Okay. OH. Okay. Now KOH. So what is the valency of potassium and what is the valency of hydroxide? The valency of potassium is 1 and the valency of hydroxide is also 1. So valency is 1 each. Okay, so this will cross multiply. The formula is how much? KOH. So this is the formula. So you will write here KOH for potassium hydroxide. Okay, and hydrogen gas. Well, hydrogen gas is H2. So this is not difficult. Okay, so now we balance this. Okay, so we balance this. So the first thing is to identify the elements. So identify the elements. The element has been identified as potassium, hydrogen, and oxygen. The same elements will be found here. So without any hesitation, we copy it down. Step 1 done. Identifying the element has been done. Count on step number 2. Count the number of atoms. So count the number of atoms. So how many atoms of potassium? 1. How many atoms of hydrogen? 2. How many oxygen atoms? 1. Yes or no? How many potassium? How many K do you see here? 1. How many oxygen do you see here? 1. How many hydrogen do you see here? I see 1 hydrogen here, then another 2 hydrogen here. So 2 plus 1 becomes 3. So there are 3 hydrogen in total on the product side. Okay. So potassium appears to be balanced. This is not balanced, and oxygen appears to be balanced. So now we know what to do. We have to balance hydrogen. Okay. So well, so let me balance this. 2 hydrogen, 3 hydrogen. Well, again, there are, I see hydrogen here also, and I see hydrogen there also. Okay, now this type of questions are a little bit tricky. Okay, unlike here, there's only 1 hydrogen, so I can easily write any number here. But then these 2, okay, because I find hydrogen in both the cases, this is going to be a little bit tricky, but no need to worry. We can, okay, we can. So basically, what will I do? Well, I already have 2 hydrogen there. Okay, this is 2 and 3. It's almost like the previous scenario, okay, which we have done. So what can I do? 2 hydrogen is here. Okay, then if I put another 2 here, what happens? 4. So can this become 4? In that case, then the answer is yes. Okay, if I put 2 here, becomes 2 hydrogen plus 2 becomes 4 hydrogen. Nah? So the number of hydrogen has now become 4. Okay, 4. Then I have to change here also. Now changing here is easy because it is all by himself, isn't it? So to make 4, it's not a big deal here. Just put here 2, 2 to the 4. So this becomes 4. Yes or no? So the hydrogen has now been balanced. Okay, but wait. Now these 2 has helped hydrogen become 4, but then these 2 also will affect potassium. So the number of potassium has changed to 2. Then this 2 also belongs to oxygen, so the oxygen number has also shot to 2. Okay, similarly this 2 has helped hydrogen become 4, but these 2 will also affect oxygen, so the oxygen number has now become 2, which is balanced now. Then finally, the only thing which is not balanced is potassium. So I have 2 potassium here, only 1 potassium here. Look, potassium is all by himself. This is very easy, this is good. So just put 2 here. Okay, If they are all by themselves, it's easy. Okay, so putting numbers here was easy. Okay, but since there were 2 hydrogen here, okay, this needs a lot of practice. So you need to practice and get familiarized with this kind of question. Then it becomes easy. Okay, with practice, you will be able to understand how to do that. So the number changes to 2. So 2K. Okay, so now everything is balanced. 2K, 2K, 4H, 4 hydrogen, 2 oxygen, 2 oxygen. So this is the balanced chemical equation. So students, I hope that you are following and understanding. Okay, so like this we will continue. I will be teaching you all the topics, okay, one by one, and I'll be focusing on important topics and important question and answers also. So we will try to solve the question and answers together, especially numericals and all that. I'll be giving prime importance to solving numericals and chemistry related questions where more teaching is required, which is actually important for you. So I'll see you in the next video. Thank you for watching.